My name is Sister Mary Rebecca. This is College Algebra, and we are on Chapter 4, Expressions, Equations, and Functions. This is the first lesson for the chapter. Today we will be using order of operations in order to simplify expressions. Let's just remind ourselves of what the order of operations are. We usually use the mnemonic PEMDAS. Sometimes people will use a little remembering device. Please excuse my dear Aunt Sally. For the P, we need to start off with doing any operations that occur within parentheses, but that includes any grouping symbol. It could also be brackets, braces. Fraction bars also count as a grouping symbol because it groups the numerator together and the denominator together. Then after we've performed all the operations within parentheses, we do exponents. Roots are included in exponents because a square root is actually an exponent that is a fraction. So since a root is an exponent, it would be included in this step of order of operations. Then we also go to the next step of multiplication and division. Do both from left to right together. So even if a division operation is more left than a multiplication, you would do it first because multiplication and division are actually technically the same sort of operation, and so you would do them together going from left to right. And then finally we would add and subtract from left to right. So we're going to simplify these expressions using proper order of operations. So here for number 1, we're going to take a look inside the parentheses first, and we see that we have an exponent, so we're going to do that first. I'm going to recopy the entire line. So 29 minus 11 minus 2 cubed is 8, plus 6 squared is 36. I can go ahead and do that operation. And then I'm going to continue to work within these parentheses. So I have 29 minus 3. And then I can go ahead and actually do this division. 36 divided by 4 is 9. Now I'm going to work from left to right, adding and subtracting, because that's all I have left. So 29 minus 3 is 26. Then plus 9 is 35, and that's my final answer. For number 2, I'm going to go ahead and perform the exponent here. 4 cubed is 64. Okay, and then I'm going to take the absolute value of -8. Absolute value bar serves as a grouping symbol, but it's also an operation. So we need to be very careful. You can't distribute within absolute value bars because it's, like I said, also an operation, but I can go ahead and take the absolute value of -8, and it's 8. But since I have a negative sign in front, that needs to remain. Then times 6 divided by 16. Now I need to multiply and divide going from left to right. -8 times 6 is -48. Now I divide. 48 divided by, -48, excuse me, divided by 16 is 3. So I have 64 minus 3 is 61. And that's my final answer. Okay. For number 3, we're going to take a look at the numerator and the denominator separately, and then at the end divide the numerator and the denominator if it is actually divisible. So let's take a look at the numerator first. I'm going to do the numerator in green. Within the absolute value bars, which also serve as a grouping symbol, I have 10 minus 12. So I'm going to take the absolute value of -2. I can go ahead and square the 5, that's 25. I'm going to leave a space for the denominator to come back to it. The absolute value of -2 is 2, but the negative sign in front remains. And now I'm going to add and subtract from left to right. So 4 minus 2 plus 25 is 2 plus 25, which is 27. Okay, now let's do the denominator. I'm going to do the denominator in blue. 9 minus 2 squared. 2 squared is 4, so I'm going to write 9 minus 4. And then 9 minus 4 is 5. So I'm going to take 27 and divide it by 5, but it isn't divisible evenly, and there's no way to reduce it, so I'm going to simply leave it as an improper fraction as such. There's no need to make a decimal of this particular answer. The general rule is if the original problem has decimals in it, then your final answer can have a decimal. But if your original problem is all integers or fractions, then it's best to leave your final answer as a fraction, even if it's an improper fraction. That's perfectly acceptable. Okay, number 4, we have 2 minus 3 squared. We'll go ahead and square the 3, that's 9. So I have 2 minus 9. And we'll square it. Go ahead and take the square root of 81, that's 9. I'm going to leave the denominator for a minute. So 2 minus 9 is -7 squared plus 9. Okay. If you were to enter this into your calculator, you're going to want to be very careful. If you enter -7 straight up and then square it, it will keep the negative in front. It'll just square the 7 and then add the negative. So what you want to do is put the parentheses in your calculator and then square it. But we can see that -7 times -7 is +49. And then 49 plus 9 is 58. Okay, I'm going to do the denominator in green. All right, I need to do the division first, so I have 10 minus 6 divided by 3 is 2. 10 minus 2 is 8. So then I have 58 divided by 8. Now this can't be my final answer because it's not reduced, but 58 is not divisible by 8, so my final answer will be a fraction. It's not divisible by 4 either, but if I divide the numerator and denominator by 2, then I get 29 over 4, and that's my final answer. Okay. Number 15 is, again, a little bit more complicated. They're increasing in complexity as we get further down on the page. So we're going to start with the numerator. It looks like we've got absolute value bars that are on the way outside, and then we've got parentheses inside and more absolute value bars within that. So we're going to start in the innermost grouping symbol, so the innermost absolute value bars. So I've got the absolute value 15 plus, and then I'll go ahead and open with the parentheses and then take the absolute value of -6 plus 2. That's -4. Go ahead and take the square root of 9 is 3. Close bracket, close the absolute value bars and square. I'm going to go ahead and put the fraction bar and leave the denominator for a minute. Then I've got the absolute value of 15 plus, the absolute value of 4 is 4. I mean, -4 is 4. It's within parentheses, so I got to keep that. Now work within the parentheses. 4 plus 3 is 7. Now that I have finished all the operations within these parentheses, I can drop the parentheses, take the absolute value of 15 plus 7, and then square it. 15 plus 7 is 22. The absolute value of 22 is 22. 22 squared is 484. Okay, now let's do the denominator. This one should be pretty straightforward. 3 minus 3 cubed. 3 cubed is 27, so 3 minus 27. 3 minus 27 is negative 24, so I'm going to recopy that in each spot. Reducing this final answer, 484, divided by negative 24, I get 21 over 121 over 6. Okay, I'm going to ask that you go ahead and do number 6. Go ahead and pause the video and take a moment to do number 6. Okay, number 6, you should have gotten 4 as your final answer. Take a moment to look at that if you need to pause it. All right, let's take a look at this expression down here. Here we have expressions that require our knowing what like terms are because we've got some variables going on here. So unlike the ones at the top, these were all numeric expressions. These algebraic expressions contain variables. So that means that we're going to need to employ the operation of distribution. So for number 7, we're going to distribute that 9. So we've got 63k plus 72 plus 3k, I'm distributing the 3, minus 30. In the end, we will divide everything by 3. I'm going to go ahead and combine like terms here. 63k and 3k are like terms, and then 72 and negative 30 are like terms. So when we combine those, we get 66k plus 42 divided by 3. Now, this would be like taking 66k over 3 and adding 42 over 3, right? Because if I were to go in the other direction, because I have a common denominator, then I can add the numerators and keep the denominator. Splitting it up, you can do the same thing. So I can take each piece of this binomial and put it over the denominator. So in the end, I have 66k over 3, which is 22k, and then 42 over 3 is 14. Okay. Number 8 is a little bit trickier because we've got a binomial that's being squared. So what does that mean? We actually can't distribute that 6 right up front. So we need to leave the 6. But 1 plus x squared is the same thing as saying 1 plus x times 1 plus x. So we have to FOIL this. So I have negative 8x plus 6. 1 times 1 is 1. And then I have 1x plus 1x is 2x. And then x times x is x squared. Now I can distribute the 6. So I have negative 8x plus 6 plus 12x plus 6x squared. Okay. That x squared is by itself. Okay, there's no like term with it. But then negative 8x and 12x, those are like terms. So I can combine those, reorder it so that my highest exponent is first, so 6x squared plus 4x plus 6. And that's my final answer.